Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 2 and our topic is still on the u-substitution based on the definition of integration as the reverse process of differentiation. And under that topic, we are going to look at the second form of integral, that is the integral of f prime of x times exponential f of x with respect to x. So when you have such kind of integrals, how do you go about it? This is what you're going to do. We're going to say that let u be equal to f of x. That is the power of the e. That is what you're saying, let that be u. Let me circle it so that you see this is what you're saying, let it be u. That will be our u. So let u be equal to f of x. And just like I told you that every time you make a substitution, you must find the corresponding differential. So what about du dx? That will be equal to f prime of x. Or you can say if I cross multiply, I'll get du being equal to f prime of x dx. So when I substitute that these two into our given integral, let me circle this other one. If I substitute u and also du, our integral now becomes, remember, f of x times dx, that is what we are calling du. So we'll now be talking of exponential u du. And then now you need to ask yourself that what did I differentiate to get exponential u? It is the same exponential u, but then there's a constant c of integration. And if I replace u, I'll get exponential f of x plus a constant c. Let me give you some examples. You can write examples. Part A, you're asked to evaluate these integrals. In part A, you have the integral of exponential 3x dx. So what will you do here? You start by saying let u be equal to 3x. So I need to find the u dx. So from here, the u dx is the same as 3. Or I can make dx the subject. So you can say dx is equals to du over 3. So I can bracket our substitutions. We substitute u and we also substitute dx. So what will our integral become? It will now be the integral of exponential u, and instead of dx it is du divided by 3, which you can write as 1 over 3 times the integral of exponential u du. So when you integrate that, you get 1 over 3 exponential u plus a constant c of integration, but you have to replace u so that we get 1 over 3 exponential 3x plus a constant c. That is very simple. Let me give you another one that is also very simple. You have the integral. I'm going to write it down. You can call it part B. And in part B, you are asked to evaluate the integral of x squared times exponential 2x cubed minus 4. 2x cubed minus 4. Integrate this with respect to x. As usual, let the power of e to be the u. So let u be equal to 2x cubed minus 4. So you need to find du dx. Du dx, that's the same as 6x. Or you can make dx the subject. It is equals to du over 6x. So let me bracket those substitutions. We start by substituting u is equals to 2x cubed minus 4. And we also substitute dx to be equal to du over 6x. Now, when I substitute this one in our given integral, we'll now be having, did I differentiate correctly? There's a correction here. This should be 6x squared. Just add the square there. Because we're differentiating 2x cubed. When you bring down the power, that becomes 2 times 3, then x raised to 3 minus 1, which is x raised to 2. So now our integral will now be this. It will be x squared exponential u, and dx is the same as du over 6x squared. So you see this x squared here will cancel with this other x squared, so that this integral can now be written as 1 over 6 times the integral of exponential u with respect to u. And if you integrate, you get 1 over 6 exponential u. Then there's a constant c of integration. So that if I replace u, my answer will now be 1 over 6 exponential. Instead of u, I'm going to write 2x cubed minus 4. Then there's a constant c of integration. So when you have such type of integrals where we have exponential function involved in the integrand, then the easiest way is to let u be the power of e. And so you can look for more problems under this kind of integrals. Another form of integrals is when you have, let me write it down. When you have this kind of integrals, I call it number 3. Another form, let's have that as number 3. And you can write integrals of the form and this is our form. We have f of x times f prime of x, the integral of f of x times f prime of x dx. So how do you go about this kind of integrals, or this form of integrals? This is what you do again using the u-substitution method. You're going to say let u be equal to f of x. It's like you have a function time its derivative and you want to integrate it. So you start by saying let u be equal to f of x. And so when you differentiate, you get du dx equal to f prime of x, or simply if I cross multiply, I'm going to get du equal to f prime of x dx. So these are the substitutions. Let me bracket them. I have u is equals to f of x, and the corresponding differential is du equal to f prime of x dx. So when you replace those in your integral, you're going to get this. The integral, instead of f of x, I'll write u. Instead of f prime of x dx, I'll write that as du. So you see this reduces now to power rule. And so this will be equal to u squared over 2 power rule, then plus a constant c. And if you replace u, you'll get f of x, because that is our u, f of x squared. This is over 2, so I can just write 1 over 2 times f of x squared plus a constant c. And so we can look at an example of this kind of integrals, maybe 2 examples to be able to explain this concept better. Write examples. You are asked to evaluate the following integrals. In part A, you have the integral of ln x over x dx. So how do you go about this? This is what you do. You see, ln x over x can be written as, this can be written as 1 over x times ln x dx. So which one do you think is the derivative of the other? One of them is f of x, another one is f prime of x. You realize that when you differentiate ln x, you get 1 over x. So straight away, our u will be ln x. So you start by saying let u be equal to ln x. So what is du dx? Du dx is equals to 1 over x. Or you can say du is equals to 1 over x dx. Alternatively, you can make dx the subject, just to be consistent, so that you understand the concept better. It is better to make dx the subject, so that here you can talk of dx will now be equal to x du. We have cross multiplied. So I'm going to substitute u where there is ln x, and also this one where there is dx, you put x du. So what will your integral become? It will now be the integral of 1 over x times u times x du. So 1 over x will cancel with this other x. So it's like you're integrating u with respect to u. And that will be equal to u squared over 2. You're adding a constant c. And what is our u? Is ln x. Replace that, replace u. So that is ln x, and remember it is squared over 2. That's everything over 2 plus c. That's very easy. Another example is part B. And in part B, you have this integral. You're asked to evaluate the integral of sine inverse of x over the square root of 1 minus x squared. integrate that with respect to x. So as usual, how else do you write this integral? It can be written as it is equal to the integral of 1 over root 1 minus x squared times sine inverse of x dx. So one of those functions is u, another one is, one of them is f of x, another one is f prime of x. So check, which one do you differentiate to get the other? You realize when you differentiate sine inverse of x, you get 1 over root 1 minus x squared. Recall what we did in calculus 1, that is differentiation of inverse trigonometric functions. So we realize that here, this will be our u. Let this be u. That will be u. So let u to be equal to sine inverse of x. So when you differentiate, it means du dx, that will give us 1 over the square root of 1 minus x squared. And from here, you can now say that the dx will now be equal to, make it the subject, it will be equal to the square root of 1 minus x squared times du. So back to our integral, it will now be the integral of 1, that is 1 over the square root of 1 minus x squared. Then there's u times dx, which is the same as the square root of 1 minus x squared du. And so this square root will cancel with the other square root. So what do you remain with? It is the integral of u du, which is the same as u squared over 2 plus a constant c. But what is u? We replace that, and you said u is sine inverse of x. So it will be sine inverse of x. This one should be squared. Everything divided by 2 plus a constant c of integration. You see how this kind of integrals, they look very nice when you're dealing with them. So this will mark the end of today's lesson. Thank you all for watching. Don't forget to subscribe to my channel. Also, don't forget to comment, to like, and also to share this video. Bye bye.